All right, our goal here is to solve the following compound inequalities, and then after we're solved, we're going to go ahead and graph those solutions. Now, looking at this, I love the OR inequalities because we're actually just solving them completely separate. So we're going to take a look at this inequality on the left. There's two ways we can start this. We can, 1, divide first, or 2, distribute. What is your choice?
Divide.
Distribute. Okay, so if we distribute, what's going to happen is we distribute the 2. We get 2x minus 6 is greater than or equal to 4. We add 6 to both sides, and we get 2x is greater than or equal to 10. And then we divide by 2. Now, did I divide by a positive or negative number? By a positive number. Therefore, the sign stays the same. 10 divided by 2 is 5. So I have x greater than or equal to 5, and then I have this OR. Now this OR is essential to include when you're writing your solution, because if you have two inequalities, there's a difference between OR and AND. Okay, it provides a completely different graph, so you have to put this in order for that to be correct. Okay, you cannot assume someone's going to guess that they know what it is. So on the left hand, or on the right hand side here, what would be the first step in solving for x? Yep, we're going to add 2 to both sides. So then we have x over 3 is less than positive 1. All right, now x is being divided by 3. So to solve for x, what are we going to need to do to both sides? Multiply both sides by 3. So we get x, and we get 3. Did I multiply by positive or negative 3? By positive, so then this would remain the same sign, okay? Now, the one thing I do like about OR equations is we can actually graph them at the same time, because all my solutions can work for this or for this. So for x greater than or equal to 5, I'm going to go ahead and put a filled in circle on 5. Why? Because of the equal to part. Which way am I going to draw? To the right or to the left? To the right. Remember, if x is on the left-hand side, if you're reading x is greater than 5, so greater than 5 goes to the right. The other thing is, see, the tip of this arrow should match the tip of this arrow as long as you have x on the left. So here again, we have x on the left. Now for this one, at 3, is that going to be an open or closed circle? Open. In which direction am I drawing? To the left. Again, if you look at the tip of the arrow, that needs to be in that direction. So this is to the left. So the combination of the green and blue is your total solution. Okay. Now there's two ways to do this. I'm not such a great fan of this one because of the 0 here. I think it kind of takes away from what's happening. But the issue is, you guys see how we have this 3 in the bottom? How many terms do we have in this inequality? We have 3 terms. We have negative 2, we have the middle term, and we have the term on the right, which is 0. Okay, now it's unfortunate that it's 0 because you're not able to truly see some of the multiplication that's going on. But when we try to remove this denominator, I'm going to multiply all 3 parts by 3. Whatever you do to the middle to solve for x, you have to do it 3 times now. Okay, so this is by 3, by 3, by 3. So then we're left with negative 6 is less than or equal to. Now here, the reason we multiply by 3 was to cancel that denominator. So all we have is the numerator left, negative 2x minus 4. And what is 3 times 0? It's 0. Now we are multiplying here. So the issue is this is not the same number. This is 3 times 0 here versus this just being 0. Okay? If this were a 1, this would have changed to a 3. So both of these numbers had multiplication being done to them. Okay, now look at the middle here. What is the next step in solving for x? Add 4. How many times do we have to add it? 3 times, because we have 1, 2, 3 terms in this inequality. So it's going to be plus 4, plus 4, plus 4. So now we're left with negative 2 less than or equal to negative 2x less than positive 4. Okay, next step. divided by what? By negative 2. Now be careful. We're dividing by what kind of a 2? And anytime you multiply or divide by a negative, you need to flip the flecha. So we have flip the flecha. Negative 2 divided by negative 2 is 1. And 4 divided by negative 2 is negative 2. So right now, x is in between 1 and negative 2. Now this is not considered standard form. You can certainly leave it like this for most situations, but generally, whenever we have an and equation, we're reading it from left to right. So if that's the case, I would put the negative 2 here, I would put the 1 here, and then I would flip again. So negative 2 is less than x, less than or equal to 1. Now the convenience of looking at it in this format is we can easily see that we're going to go from negative 2 to positive 1, and it's going to be everything in between those two, okay? Now let's say you were going to graph this. It works the same way. We go to negative 2 and then open circle. And I'm like, oh, you know what? X has to be greater than negative 2, so that's going to be everything to the right, okay? Then I look at this one, and it's like, all right, well, x, because we're reading from x is going to be less than or equal to 1, so that's 1, and it's equal to, so filled in circle, but then it's everything this way, and then the in between, it's because that's the two spots where it's a combination of the two. Okay. All right, last example. We want to solve and graph. It's an OR inequality. So for this one, let's start with the one on the left. First step in solving for x. We're going to subtract 6 from both sides. So then we're left with negative 1/2 x is less than negative 2. What do we want to multiply both sides by? We can either divide by negative 1/2 or multiply by negative 2. Because we want to remove that negative sign. Okay, so on the left-hand side I have x. On the right-hand side I have positive 4. However, yep, we need to flip the flecha because we multiply by a negative number. All right, so then we have OR in the middle. So OR okay. First step for the last inequality. Distribute the negative 2, so we get negative 2x minus 2 greater than or equal to 10. All right. Also, I just do want to point out we also could have started by dividing by negative 2. All right, if that's a preference for anyone. All right. Next step. Add 2 to both sides. So we get negative 2x is greater than or equal to 12. Final step. Divided by negative 2. So we get x. We get negative 6. However, flip the sign. Okay, so let's take a look at what this looks like on a graph. We have x greater than 4. Is that open or closed? Open, what way? To the right. And then for the purple part, is it open or closed? And then what direction? To the left.